Okay, welcome back, ladies and gentlemen. Today we are going to continue on with our discussion of biological macromolecules. So let me open up a slideshow here. All right. Let's start off by just talking a little bit about carbohydrates from yesterday. If you remember, carbohydrates have a basic ring structure, and you can put a bunch of those small rings together to form your large polymer or polysaccharide. And they have pretty much one main function, and the function of carbohydrates is to provide a short-term source of energy for organisms. So sugars are your quickest, okay, they can be broken down the fastest and therefore provide the shortest term energy source, whereas your polysaccharides or your longer chains take a little bit longer to break down, so within a few days you can get the energy that you get from those things. And that's why you eat pasta a few days before wanting to exercise for like a big race or something like that, because you need the extra energy to be broken down over a long period of time versus quickly, like sugar. So those are carbohydrates, and we talked about those yesterday. If you want to review that material, go back and look at yesterday's lecture. Today we're going to be talking about the second class of essential biological macromolecules, which are also known as lipids. Okay, and lipids contain two things. Lipids contains fats, and lipids contain oils. And we're going to talk about the difference between fats and oils today. So fats. Fats are lipids that are commonly found in the solid state at room temperature. Okay, so they're solids at room temperature. And most often lipids or fats are lipids that are produced by animals. Okay, so let me give you an example. Lard is produced by animals. Butter is produced from animals. And then obviously the fat on a nice T-bone steak or any type of beef steak or whatever you enjoy eating, chicken, whatever meat that you eat that has fat on it. Those are all fats, because when they're sitting on the counter, they are solids. They are not a liquid at that particular time. Oils, on the other hand, are liquid at room temperature, and therefore they are lipids that are produced by plants. Okay, so when you think of an oil, you're thinking of olive oil. I think of vegetable oil. All things that are used in cooking, oils are typically produced from plants, and therefore are slightly different in structure than those of fats. Now, the difference between lipids and carbohydrates, they both serve as an energy source, if you notice. However, the difference is that lipids serve as a longer-term source of energy. So carbohydrates only provide energy for a few days. And you can only live on the energy that you get from carbohydrates for a few days. Whereas if you have lipids stored, or fats, you can burn fat for a long period of time. And that's why a bear chooses to store fat and eat high fatty foods before its hibernation, because it can use that fat as an energy source long term throughout the winter during its hibernation. So those are for long-term energy storage. Like carbohydrates, they also have the elements carbon, hydrogen, and oxygen, and therefore are organic, but they don't have any other elements, just carbon, hydrogen, and oxygen. And they have this characteristic of being hydrophobic. Hydro, again, we talked about meaning water, and phobic meaning to be scared of, like a phobia. So hydrophobia is the fear of water. So lipids do not mix with water and cannot be dissolved because they are hydrophobic. So when we talk about the structure of lipids, okay, there are two types of monomers. The first type of monomer that you have is called a glycerol. And the reason it's called a glycerol is because it has these 3 OH molecules on the right-hand side of the molecule. Okay, and these are going to be important for dehydration synthesis, but they also characterize this molecule as a type of alcohol. So your glycerol molecule is depicted here. The other type of monomer are called fatty acids. All right, and there are 2 different types of fatty acids. You have saturated fatty acids, which means that they are saturated or full of hydrogens. So if you look, every single carbon has as many hydrogens as it possibly can on its structure. Okay, so it's saturated with hydrogens. And what that causes is saturated fatty acids cause it to be solid at room temperature. So these are typically your animal fats. On the other hand, you have unsaturated fatty acids, which means that they are not saturated or not filled with hydrogens. So if you look at this fatty acid, it still has its carboxylic acid group here, just like the saturated fatty acid. Both of them are similar right here. However, if you look, this carbon is not saturated with hydrogens. I could break one of these bonds and create a hydrogen here. And as a result, you notice that does not nearly have the number of hydrogens that the saturated fat does. What this causes is it causes the fatty acids to kink or bend, which makes them a liquid at room temperature. And these are typically your plant oils. Okay? Or for those people who are good with nutrition, these are your polyunsaturated fats. Okay? But these are your 2 different types of monomers, a glycerol and fatty acids. So let's see how those are put together in order to make the fats that we know and store in our body called triglycerides. So if you look, we have a glycerol that is depicted here. And right now I'm circling the OH groups on the glycerol. And if you notice, there's 3 OH groups. That causes the glycerol to be able to bond to 3 fatty acids. Now if you look, the COOH here on each one, these are your acidic groups, so that's why they're called fatty acids, because they are acidic. And this is the region in which they undergo dehydration synthesis. So they can take off an H and an OH from each one, and you create your 3 water molecules. By doing so, you then form a larger molecule or a polymer, which is a triglyceride. And the triglyceride is called a triglyceride because tri meaning 3, okay, and glyceride meaning that it has a glyceride backbone. So we're going to watch this again, just so you guys can see how it happens. Maybe not. My computer again is acting up. I think it likes me very much. Okay, so we were just talking about triglycerides. And triglycerides are polymers that are composed of 1 glycerol monomer and 3 fatty acid monomers. And they are formed through dehydration synthesis. And again, broken down through hydrolysis, which we have talked about in the past. And again, if we look at our basic triglyceride molecule, you have the green representing the glycerol here, and you have 3 fatty acid chains on each glycerol. So this is characteristic of your triglyceride. How I usually draw this is I show the glycerol looking like this solid backbone here that I'm drawing, and the fatty acids coming off like this. Okay, so tomorrow we will talk about proteins, but for tonight, make sure that you fill out your note packet as well as your facts and questions sheet so we can go over that as a class tomorrow in the beginning of class. Okay? Have a great night, and I will see you tomorrow in class. Bye.